Hi, Nick Collier here, and this is my shop. Come join me. We'll have some fun.
Hey, Nick Collier here again, and it just so happens that all of my projects are either finished or on hold, and I got a little extra time, so we're going to kind of go back to this follow rest that I'm working on, and you know, just continue with that process. So follow along. We're going to have a good time.
All right, well, we've got our some of the V's cut to relieve that. We've got the top edge, or the top bolt supported. Now we need to support the bottom one. And I've cut one piece, and I believe I need to cut a second piece, and then we'll go ahead and weld those on, and we'll see what we can do. And we'll be back. Okay, so since we're sitting on the piece of cardboard as our pattern, and I can't really heat it up because of course I'll burn up the cardboard, we're going to just go in and just tack this thing together and then take it off, preheat it, get it all nice and warmed up, and then come in and probably arc weld the junctions there. So let's go ahead and do our tacking. We did move off the mark here just a little bit, and the same with that one. But I think we can just kind of grab it and pull it back in. All right, I tell you what we're going to do is get a hammer and tap it back. Yeah, that's going to pull right back in. So let's get that one locked in. Good. Get everything set back up again.
Well, hell's bells, I'm not going to know until editing how much of that welding you got because the camera went dead, as usual. But we got somewhere, and we got the whole thing welded together, and it's square and flat, and we need to let it cool off. Okay. Okay, well, going by the design of my old follow rest, the one that doesn't fit my lathe, I notice that if this is center point, this rotates out beyond the 90 degrees, maybe by 10 degrees or so. And I'm guessing just to kind of hold it in place rather than just sit on top of it, it just kind of kicks it over in front of whatever's turning in order to kind of keep it pushed up against the back the adjuster. So what we want to do is we want to kind of do the same thing and bring that forward just a little bit, and we'll swing over to the one that I'm making, and notice that we're about 10 degrees closer in. Actually, you know what, let's make it just a little bit more than that. How does that look? I think that looks pretty good. So we're going to go from center point out to about something like that. That looks pretty good. And then from center point out this direction, and there's our two lines. This one is, it's fine. Okay, so then, you know, this is all just random for me. We're just going to drop this on the mill and bore a hole through both of these, and then thread that hole to fit the shaft. Where's our shaft at? And here's our shaft. So then the shaft will adjust in or out to that center line. Okay, so we will be back. Well, it turns out that my mill doesn't drop down this low, so we're back to the drill press, which is just fine in this situation. There we go. Pretty close. Ready to go. Ready to rip. All right, let's see if we can drill this hole without the camera going bad on us. All right. All right, so we've got our hole drilled, and now we need to run the tap down there. Okay, so there's our tap. Now, one thing I hate about, and I think this is American made,
Yeah, made in USA. Of course, it's, you know how it is. I don't know if you know this, but USA, without the dots between the letters, is USA, China. USA, China. That's the name of a town in China. Let me bring this in closer to you. It's such a fucking scam. So, made in USA, no dots means that it was made in China. Oh man, I just like, that just burns me up. So, it is Chinese made after all. And guess what? They didn't put a center hole in there, so there's no guide to go with. Yippee. So we just kind of have to fake our way down into this hole. And one way I'm going to do it is to bring this, let's close up the... And actually, you know what? We could put a center in there, now that I think of it. And then just bring the center down within striking distance. And just visually stay right on that center line. Of course, my vise is going to move. Yeah, right. Let's see here. What can we do? All right, we got the vise all clamped down. Now we got our center just pointing at that center dot, which is all they gave us in this tap. So we'll just kind of stay with the center dot as much as we can. And oh wait, we can do that. The bar hits. The other bar doesn't hit. Okay, and I realized, not too late, luckily, that I need to have a flat boss on here that is perpendicular to the bolt hole. So we need to come in with a mill and mill out that a kind of a countersink, not a countersink, but a flat, so that the lock nut has a place to land. Otherwise, it's just going to be floundering around. And all I'm doing is just getting myself generally lined up here. That looks pretty good. That looks pretty good. I think we're going to be happy with that. Take this out. Oops. All right, well, let's zero the DRO out, and we'll just take our table over a little bit and come up with a, looks like maybe 11/16. Nope, 3/4. Yep. Put our 3/4 collet in, snug it down a little bit, see if we can get and maybe we can go down just a bit more. There we go. We're at the maximum with this table, maximum depth.
Okay. Bring it back to 0. And there is our flat. Everything's tight. Let's make sure everything's tight. Yep. Yep. Okay. And we just come down until we square up. Let's see what that looks like. We're getting there, a little bit at a time. And what I've been doing is, instead of going down with the quill, I'm coming up with the table, and I get a little bit more consistent travel. Although it's still shattering like a son of a bitch. Well, it just jumped. And we need to have a bit more grip there. All right, we tighten the vise up a bit more. Well, that's a lot better. All right, well, for now, we've got a good 3/4 or more of this showing. I'd like to get down just a little bit more, just to get just a little bit of that edge going. And I think let's go ahead and do that. We'll just travel slower. Let's see if we can change our belt. Let's try that. Oh, now they're slow. We might even be able to do this without chatter. Yep. Okay, that's better. We got a nice clean surface there. It's touching around this side here. It doesn't need to touch all the way. we're going to have enough trouble on the other one, which is at a super angle. So I think we're going to be in good shape right here. Let's take this out. I'm going to move you back a little bit. Oh, maybe not. And we're going to rotate this. And while we're over here, I want you to check out this new tool I just got. It's not a plasma cutter. It's a CNC table, but it kind of does the same thing. And you know, it's pretty much a fraction of the price. I think what are the plasma tables going for 10, 15,000? This was $100. I like it. And in the 60s, I actually used this when I worked in a shop in the San Francisco Bay Area, and I loved how it worked. And of course, back then, that's all they had was this. And it's called a pattern torch, or sometimes a pantograph torch. So let's check it out and see. You know, it's not totally hooked up. It's just kind of barely bolted there. I got to dink around with it a bunch to get it to work. I mean, not to get it to work, but to get it functioning. But let's check it out. And so what happens is that the torch head is right here, sits directly below this pivot point up here on top. And the pivot point is and I'll kind of turn, well, I don't have it plugged in. The pivot point is a real slow moving motor. So basically what you do is you come in, and there's a bar that goes across the top of this. You come in, and this is magnetized, and it literally connects to a pattern that you cut out of steel up here. And it follows the pattern all the way around, going, you know, the whole distance around what you want, and the torch down here cuts. So, you know, back in the day, in the 60s and early 70s, this was the tool. And who knows how much it costs new, but it's all analog. There, you know, I'm thinking there might be a vacuum tube or two in here, but other than that, that's basically what we've got. Switches on, off, and a rheostat, and this thing's been running for, you know, what, 50 years. What I'm trying to do is get this thing into some kind of hold, and I'm not seeing any way. Oh wait, no, of course. Flip it. There we go. Come in from the opposite direction. That should do. We're going to need some more shims on the other side though. Okay. This is going to want to swing in. Now the problem is we need to know where that angle is. First thing we do is turn it around so we can see it. Next thing we do is we can bring it out here and put a couple of shims in behind here. That looks good. And snug it up and see what we got. Not too bad. Let me tighten everything up. And we don't need to be trammed in this way or anything, because this is basically a straight hole right down through the center.
And I'm thinking what we want to do is create a flat right in the center of that so that when we go in with the drill bits, they don't walk from one direction or another. Bring it up. That's good enough for that. We need to move the vise over that way, oh, a couple of inches, which means moving both vices. I always don't want to move my other vise because it's all trammed in, but you know, hey, it is what it is. Good center there. Let's get started here. And we can go a little bit faster. All right, well, that's not a bottom cap, so we're going to have trouble with that. What can we do? All right, well, we're going to move it back and forth a little bit just to get a flat going, and then we'll drill a hole. All right, well, we got enough to get something started. And I think that's going to be good. All right, let's go.
well, hopefully we got this whole thing locked down. Now we're going down about, I don't know, 3,000 or 4,000 per pass. And just kind of slowly working our way down to get this thing flat.